We're here today to put on a presentation for Balchem Corporation. We're going to be talking about myth busting with transition cows. So we're going to be taking a lot of concepts that are currently held in the field and really evaluating whether those concepts are really true or not. I'm Dr. Ric Grummer, Professor Emeritus from the University of Wisconsin, and this is the myth busting series from Balchem. So myth number one is high blood NEFA and BHBA are bad for the cow. All right, so we've gone into an era now which we're doing a lot of testing, a lot of blood sampling, sometimes for NEFA, usually not NEFA because we don't have any slick on-farm meters yet, at least that I know of, but you can send them out and have them done commercially. They're a little pricey. The bigger one is BHBA, or beta-hydroxybutyrate. And we're having a lot of that done, and really the concept here is that these two metabolites in blood are perhaps an indicator of body fat mobilization by the cow. All right, so what I've got listed here is a 10. And I probably could have maybe even doubled this list if I really would have tried. And this is material that's in the scientific literature that people are out at conferences like this talking about. It's getting into the popular press of why NEFAs and BHBA are maybe a bad thing. Right? So we can start down at the bottom. Potentially depresses dry matter intake. This was some work that actually was done with one of my final students. Exacerbates insulin resistance, which sets off kind of a NEFA cascade, vicious cycle. Implications on having adverse effects on immune function, inflammation, greater stress on the liver. You get these fatty acids being oxidized. Epidemiological studies saying, well, maybe if we have high NEFA, we have a lower likelihood of getting that cow pregnant. Maybe the liver doesn't make as much glucose when we have too much NEFA going into the liver. More epidemiological evidence, maybe we have increased DAs, and as my figure showed before, increased liver fat or perhaps ketone production. So there's a lot of reason why people don't like NEFA and BHBA, and that's why we test, and that's why we say, well, if they're this high, man, you may have a problem. But I also put together a list of why we might love NEFA. That's our monitor of fat mobilization in BHBA. Well, they can provide energy for tissues, including the mammary gland, and they can provide precursors for milk fat synthesis. Pretty short list. But you got to admit, it may be short on quantity, but it's high on quality, right? It's pretty important reasons why these are good compounds. This is a study that's published quite a few years ago, but sometimes the oldie moldies are the best that are around. And this was a study that was done, published by Iowa State University. It came from a study that was done at a multi-university study. I think 4 or 5 Midwest universities had split their herd in half. And half of the cows they bred using average semen, to the other half of the cows they bred above average semen, and they kept these two different lines going. Basically 2 subherds, one average and one genetically superior. So this was after a couple of decades of doing this. They went and they summarized the data. Well, here's the milk production. You can see there's quite a big difference there, about 8 kilograms in milk production. So that's like 17, 18 pounds of milk difference between these two subherds. Here's the fat-corrected milk similarly, a nice big difference that they achieved. And they wanted to study these cows, right? How they behaved. I want to point out here that these differences are right out of the gate, okay? Right out of the gate. Bango. You can see the differences in milk production. Let's take a look at this diagram. This is feed intake. And the first 2 weeks, no difference. 3rd week, maybe starting to split. It wasn't significantly different until 5 weeks out between the two types of cows, the average and the genetically superior cow. So that genetically superior cow makes more milk right out of the gate, but she doesn't eat more right out of the gate. So this is energy balance. And here's the high group. In the solid line, they're in a more severe negative energy balance because they're making milk, but they're not compensating by eating enough yet. So take a look at our NEFAs here and our BHBAs here. The genetically superior cow has higher NEFA and higher BHBAs. So why do we hate NEFAs and BHBAs so much? That's what we've bred cows to do. This was a recent study just published out of UW-Madison by Heather White. Basically, they went into the UW herd, sampled 570 cows. 20% were hyperketonemic as using the 1.2 millimole per liter cutoff. And then they looked at milk production. So these open squares are the high BHBA cows versus those that were not elevated BHBAs. Well, they made more milk. Now, we're a little confounded here because these high BHBA cows got 3 days worth of propylene glycol at 300 mils per day. So you could say, well, maybe that's a propylene glycol effect. Yeah, I don't think so. I mean, it's, from a purist standpoint, it's possible, but I don't think 3 days of propylene glycol allowed those cows to make, 5 to 7 kilograms more milk for that entire period. So the authors concluded that this may suggest that higher producing cows become hyperketonemic due to the high energy demand for milk production during the current lactation. So the bottom line is like with most things we measure in blood, we've pigeonholed ourselves into a number. And if you're above that number and a certain percentage of your herd is above that number, this is an alarm. You got issues. I field about one of these questions probably per week on average. People calling me, oh man, I got more than 15% of my cows testing above 1.2. I guess I have a problem, but my cows are milking like crazy. I tell them to relax, okay? Unless there's something else that you can identify that may be problematic, that would be associated with high BHBAs, just relax. Everything's fine. Don't worry about it. Don't worry about being so rigid on those cutoffs.